Welcome to qnawire.
Hello everyone. This is the solution to problem 6 of chapter 24 of college physics. For the first part of this problem, we're asked to draw the field lines, the electric field lines of a situation where we have a positive charge Q and a negative charge of -2 times Q, placed at a distance d apart. So what you want to pay attention to here is that the field lines are going to they're going to be leaving the positive charge and they're going to be arriving onto the negative charge. And this is just by convention that the electric field lines follow the direction that a positive test charge would move. And obviously that would be repelled by a positive charge and attracted to a negative charge. So that's one thing to pay attention to. And the other one is that because the charge on the -2q charge is bigger, the field lines are going to be more concentrated over here. So ideally, there should be like twice as many field lines. If I drew a circle around here, and one around here, then there should be twice as many field lines arriving into here than leaving from here. Now, due to the capabilities of the drawing tools that I'm using, this is kind of impossible, but imagine that that is the case. So this is what the field would look like. And so that's part A. Now for part B, you're asked to find what the electric field is at a point that is equidistant from the two charged objects. So for this part, you need to know that the electric field is given by this formula that you get from Coulomb's law, Coulomb's force law. And so here, r is the distance between the charged object with the charge q. This could be either plus q or minus q. So actually, let me just call this little q, just so that you would not confuse it. This is some arbitrary charge that's sitting, say, over here. Then if I'm trying to find the electric field generated by this charged object that has q, then I'm going to be looking at a point which is a distance r away from this charge, and it's going to be moving either to or away from this charge, depending on whether what the relative charge of these two are. So like if q is actually positive, then the electric field is going to be pointing away from it. If q is negative, then the electric field is going to be pointing towards it. So here, at a point that is d over 2 away from both plus q and minus 2q, we have the electric field has a contribution such that there's k times q over d over 2 squared. So again, this is the distance from the charge generating the electric field and the charge feeling the electric field. And so this is pointing in the positive x direction. So this is x, and it comes with a positive sign. All right. And then the other one is going to be k times the charge of the object is now 2q. Sorry, it's minus 2q divided by d over 2 squared again, and it's pointing in the negative x-hat direction. So ideally, what you would say is that, this is the charge, and because it's a negative charge, I'm going to put q as being equal to minus 2q over here. So if this little q was minus 2q, but then I know that it's going to be a negative charge, so I know that it's going to be attracting. So the electric field is going to be pointing more towards the positive part of the axis. So then these minuses cancel, and what you end up with is going to be k times q, which you can factorize. And then you're going to have 2, you can actually factorize 1 over d squared as well. And then this is going to be 1 over a half squared, which is 2 squared, which is 4. And then you're going to have 2 times the same thing, which is 8. And so you're going to end up with 12 times k times q over d squared. And this is going to be pointing in the positive x head direction. So this is your final answer.